Okay, so now we're going to look at factoring a trinomial, something that, so if we follow the flow chart, whoa. All right, so here's the problem we're doing. Is there a common factor? Is there something that all three factors have that I can pull out? No. 12 and 20 have common factors, but if all three don't have it, I can't do anything. All three have to have a common factor for me to take it out. So there isn't one. So let's follow the no path. Is the value of a equal to 1? Yes, remember a is just whatever is in front of the x squared. In our case, it's annoying because they're using a's instead of x's. But a would be whatever this number is right here. And since there isn't one, it's really just a 1. So b would be, what's b? Negative 12, and c would be 20. Okay, so is the value of a equal to 1? Yes, it is. Is the value of b equal to 0? No, it's not. Find factors of c that add up to be b. Watch your signs. That's it. A, b, and c. You want factors of this that add up to be that. Do you remember doing this? So what are factors of 20 that add up to be negative 12? Negative 10 and negative 2, right? You need two numbers that multiply to get you positive 20, yet add to be negative 12. So that has to be a minus 2 and a minus 10. Do you remember doing this? You can always check your answers by foiling that back together. You can just do it quick in your head. A squared minus 10 minus 2. Yep, that's minus 12a. And then negative 2 times negative 10. Yep, that's positive 20. So when a is 1, your life is pretty easy. You just have to find factors of c that add up to be b. That's it. So try 10. 10 is that same situation. There's no common factor to take out. If there was, you would. I can follow the flow chart, but you probably already know what to do. You're just going to find factors of c that add up to be b. Did you find them? So this time you want factors of positive 48. Remember, factors are just numbers that multiply together to get you 48. So there's a whole bunch. 1 and 48, 2 and 24. 3 and something. 16? Is that right? 3 and 16? It is? Oh, good. Look at me. There's tons of them. But I want the pair that add up to be 14. What are those? 6 and 8. There you go. And you're done. When a is 1, your life is so easy. You just find factors of c that add up to be b. Try 12. You got it? All right. So this is following the same path. A is 1, right? So all I have to do is look at c and find factors that add to be b. What's c in this case? Negative 2. What's b? 1. So you want two numbers that multiply to get you negative 2 that add to be positive 1. What would those be? What is it? A positive 2 and a negative 1. If you are not so good at these, foil it back together and just make sure that your signs work. I can't tell you how many kids have the numbers right, but they swap the signs. Right? Take a minute and just multiply, foil it back together. You don't even have to write it. Do it in your head first. Outside minus 1, inside plus 2. Minus 1 plus 2. Yep, that's plus 1. And then positive 2 times negative 1 is negative 2. Don't lose the points on the signs when you can so easily check them. All right? Now, let's go back to 11. Okay, uh-oh, a isn't 1 anymore, so what do we do? Oh, So we have to check if there's a common factor. If you don't check for a common factor, you are not doing yourself any favors. So do you think there's a number that goes into 6, 30, and 144? 6 does. Oh, happy day. By the way, is it 24? There we go. Now we're happy. What happens with this 6? Nothing really. It's just part of the answer. So that's 6. I'm just going to bring it down. It's just part of the answer. I can kind of ignore it now. But you can't forget about it. If your answer line doesn't have a 6 on it, the two things that you multiply together, you're never going to get back to the original. So I need it, but I'm done with it. Now I'm just looking at what's in the parentheses, and now I'm going to factor that. A is 1, so I need factors a negative 24 that add to be a positive 5. Those would be a positive 8 and a negative 3. There you go. So this entire thing here, all of this is your answer line. If you leave out the 6, I'm going to have to take points off, because if you just multiply x plus 8 times x minus 3 together, you're not getting the original. You need that 6. Don't forget about it. So my advice to you, if there is an answer line and you factored something out, right away, before you do anything else, put that number on the answer line so you can't forget it. It's already there. All right? So please be careful. So, easy enough when A is 1, right? Right? Yeah? Well, unfortunately, A isn't always 1. Let's jump to something like, oh, you know what? Before I do that, let me just ask you this question. How would you factor something like this? That. A is 1, so life should be easy. I just need to find factors in negative 3 that add to be 10. What are they? There aren't any. There aren't any. So what does that mean for this? That just means that that expression is prime. Oh, wait. This one's not me. Perfect. So this one is. I know. There are no factors in negative 3 that add to be 10, right? Just like if I asked you to do the prime factorization of 17, it's already prime. So your answer here would just be that it's prime. You can't go anywhere. Okay? So just if you ever see that, that's all you do. All right, so now let's jump to one like, oh, do I want to do 18 already? Actually, let's start on 23. Okay. Now, let's follow our flow chart on 23. So here's the one we're doing. Let's zoom out a bit so we can get more of this flow chart in there. Is there a common factor? Can you take something out from the beginning? No. Oh, we wish we could, because I would love that A term to turn into a 1, but it's a 3. And 3 does not divide into 20, so I can't take it out. All right, so no. Is the value of A equal to 1? No. Is the value of B equal to 0? No. Whoops. So now we're here. You have to factor by one of these things. Now, you learned these methods, at least the first two, I'm sure, in Algebra 1. Whether you remember them or not, I don't know. I also don't care what method you use. So if you know how to factor this and you have your own method and you do it and you stick to it, that's fine, as long as it's right. So, one method is guess and check. That's the one where you're literally guessing the factors of 3 and the factors of 12, and you guess combinations until you get the right pair. That's totally fine. If you want to guess and check, guess and check. The downside to guessing and checking is when these n numbers have a lot of factors. 3 is not so bad. It only has 2 factors, 1 and 3. 12 has a bit more, but when your n numbers have tons of factors, you're going to spend a long time guessing and checking. But the more you do it, the better you get at it. So you get very good at it. So if you're a guess and checker, you guess and check to your heart's content. The other method is factoring by grouping. So let me show you this one and see if this is what you remember. Sometimes this is called the A times C method. So we're going to do 3. I'm going to call them X's because I hate other letters. I know. I should love all the letters the same, but I don't. All right. Do you remember what to do with the A and the C? Well, you're going to multiply them by each other. So you multiply A times C. So you get 3x squared plus 20x plus, oh wait, what am I doing? I'm not doing it right. Sorry. A times C is 36. You just come over here, and now you want factors of 36 that add up to be 20. What are factors of 36 that add to be 20? Are there any? I might have picked a terrible example. Oh, yeah, there are. You got the pair? What is it? 18 and 2. All right. Then you rewrite this, but instead of writing 20x, I pop these two guys in there. So I write it like this: 3x squared plus 18x plus 2x plus 12. Isn't 18x plus 2x really 20x? Right? I haven't changed anything. I just split that into 2 parts. And by the way, it doesn't matter which one goes first. You could have said 2x there, 18x there. It doesn't matter. And now, this is why it's called factoring by grouping, because I'm going to group the first 2 together and the last 2, and I'm going to factor them separately. I like to actually draw a line. You might have done parentheses in another class, whatever you're comfortable with, it doesn't really matter. On this side, I factor out the common factor over here. So for just 3x squared plus 18x, what can I take out of those two? 3x. And I'd be left with x plus 6, right? If I'm just factoring that side. And then I come over here and I do the same thing. What can I take out of 2x plus 12? 2. And I'm left with x plus 6. The magic is supposed to happen right here. These 2 parentheses are supposed to be exactly the same. If they're not, something's wrong. Either you didn't factor out the greatest common factor, like if you had only taken an x out of here and not a 3x, that parenthesis wouldn't match that one. And then you go, oh, I should have taken out a 3x, not just an x. These 2 parentheses have to be totally identical. If they are not, go back and figure out what's wrong because something's messed up. Now that you have them, your 2 factors, one of them is just whatever is being shared, x plus 6, and the other one, oops, is just whatever is out in front, 3x and a positive 2. Okay, so again, this is called factored by grouping. You might have heard it as a C method. I don't know what else you could call it. Whatever name you give to it, I don't care, as long as you know the method. There is yet a third way. You ready for this third way? You may not like it. If you don't want to know about it, you can tune out for a minute. Because I know it gets confusing when you have multiple ways to do the same darn thing. I know. But here's my secret. This is my favorite. I actually think it's the easiest. That's me personally. So here's the new method, which you may not know. It starts off similarly. I'm going to multiply A times C. But here's the difference. I'm going to drop off A, and I'm going to do A times C and put it right here. That's what I started to do on the other one. Now, I factored this just like I normally would. Look, because look, A is 1 now. So factors of 36, they have to be 20. 18 and 2, right? Here's the one downside with this, is that kids always forget to do this next step. They stop right here. They think that they're done. You're not done. Since you multiplied by 3 in the beginning, you now have to sneak in and divide both of these things by 3. Have to. So, 18 over 3 is just 6. Now, this doesn't just become a nice number. So what happens, I would reduce the fraction if I could, but I can't. You just take that 3 and you stick it in the front. 3x plus 2. I know. It's so weird. So whichever way you like, you go for it. Believe it or not, it's the same math. It's just sort of set up a little bit differently. You're doing the same ideas. Okay, so let's try another one. Say we did, let's go back to 18. So here's 18. You have to factor out a common factor if there is one, no matter what method you're doing. So please do not forget step number 1. Check, is there a common factor that you can take out? No, but if there was one and you didn't take it out, it's a disaster. So please take the time and look. All right, there isn't one, so now you do what you want. You can try the AC method, or you can try this new, by the way, the new method doesn't really have a name, so I just call it the new method. Should I give you a minute, or do you want me to do it? You want to try? Or do you want me to walk you through? Okay, I'll walk you through. I'm going to walk you through the new method. If you want to do another method of your own, do it. Yep.
Is this number 18?
This is 18. Did I mess up?
Yeah, no.
I have X's instead of V's.
Yeah, I just thought it looked different. Sorry.
Yep. Okay, so the new method, if you want to do a method of your own, go ahead. The new method says multiply A times C. Drop A off. But now that's a minus 120. Now I factor this like I normally do, because A is 1. Oh, yay. So I need factors of a negative 120 that have to be a positive 7. Let's see, I don't know them off the top of my head, but I'll just try some. Positive 10 and a negative 12? Nope. How about a positive 30 and a negative 4? Nope, too far apart. Positive 20, negative 5? Nope. But I'm getting closer. I wonder if 24 goes in? Yep. Positive, oh, whoops. 20 is 6. Dopey. So that's 14. 24 and a negative 5. I gotta go smaller. 18. Nope. 15 and 8. There it is. Positive 15 and a negative 8. So once I have my two factors, x plus 15, x minus 8. Do you know what I do now? Do you remember? You don't stop here because that's a disaster. You sneak in. Since you multiplied by 3 in the beginning, now you divide both of these by 3. And then I just simplify. 15 over 3 is 5. I cannot simplify 8 over 3. If I could, I would have to, but I can't. So I'm just going to take the 3 and I'm going to sneak it in front. 3x minus 8. So I don't care what method you used. Guess and check, factor by grouping, we're all going to end up here. And remember, it's just multiplication, so it doesn't matter if you have the 3x minus 8 first and then the x plus 5. But you should definitely have the plus with the 5 and the minus with the 8. How did you do? Okay-ish? I'll take that as a yes. All right, let's look at 17, because this one has something else going on. I guess I don't mind p's too much. I'll leave the p's in. Someone tell me what to do first. no matter what method you're going to do. What should you do first? Yes, there's a common factor this time. I hope it's 6, because that would make my life way easier. Does 6 go into 80 and 200? No, we wish. But I could at least take out a what? A 2. I can at least take out a 2. That makes my life a little bit easier. So now what happens with this 2? Nothing really. It's just part of your answer. So sometimes I just do that to remind myself, hey, don't forget about that. Now I just got to focus on what's in here. There's no more common factors. It's worth double checking. Can I take something out of 3, 40, and 100? No. But if you could, that meant that you didn't take out the biggest in the beginning. And you always want to take out the biggest. So do take a second to just check. Yep, there's nothing else I can do. So now, either do the new method, guess and check, or do your factor by grouping method. How about I do a factor by grouping to remind you? I'll walk through that one again. So that one starts off the same. You still got to do A times C, that's 300. I still have to find factors of 300 that add up to negative 40. So far it's no different than the new method. So factors of positive 300 that add up to be a negative 40. So they're both going to have to be negative. I have them, do you? What 2 numbers? Tell me about the signs of these numbers. If they have to multiply to be a positive number, but they have to add to be a negative, what's the sign of both numbers? They're both negatives. So give me 2 negative numbers that multiply to be a positive 300 that add to be a negative 40. 30 and 10, you got it. So it's negative 30 and a negative 10. So if you're doing factor by grouping, you just pop those 2 in. Minus 30p, minus 10p, and then plus the 100. Order does not matter. So if you had the minus 10 before the minus 30, don't worry. All right, and then I like to actually draw a line right after the second term. Be careful not to draw it through that symbol, because then you won't know if that symbol was a plus or a minus. So always draw it right in front. And then you just factor each side. So what can I take out of 3p squared minus 30p? I can take out a 3p, and I'm left with p minus 10. Over here, oh, I'm glad that one like this came up. What would you take out over here? Negative 10, right. If that first term is a negative, you're going to take out a negative. So that would leave me with p minus 10. Notice my 2 parentheses have to match, and they do. If you had only taken out a 10 and not a negative 10, you would have had negative p plus 10, which is not the same as that, but hopefully you look and you're like, oh, look, they're only different by the sign. I should have taken out a negative 10 in the beginning. Now you have the 2, your parentheses match. So one of them is p minus 10, the other is 3p minus 10. Hooray! Would you like to know a very lazy check, but I hope that you at least do this? If you're not gonna, here's what's supposed to, you should multiply all this back together and check that you really do get back to the original. I have a feeling you're not gonna do that. Will you at least do the lazy check for me? It's so easy. Here's the lazy check. And it's not guaranteed that you're going to get it right, but at least you know you're not totally wrong. You just multiply all the first numbers, 2, p, and 3p. If you multiply all that together, what do you get? 6p squared, which should be that first term. At least do that for me. What's nice about at least doing that is if you had forgotten to bring down that 2, and you multiply p times 3p, that's only 3p squared. And you're like, oh, shoot, it was supposed to be 6p squared. Oh, yeah, I took out a 2 and I never wrote it on the answer line. Now I won't lose a point for something dumb. Is that okay? Ish? Do you remember doing this? Whatever method you used, factor by grouping, or... Let me just, out of curiosity, this new method, where you multiply and you divide like this. Can you raise your hand if you have seen that before? My kids have. If they weren't playing on their phones, they would know. You don't remember? No? Victoria, no? Oh, we did it.
You didn't teach us this.
I did. In Algebra 1?
I only had you for part two.
Yeah, that's where you do it.
I think you did.
I think we called it the some guy's girlfriend's method.
Yeah, I know.
Oh, jeez. Well, we did it. The reason why we called it that was because we found some video, and it was this guy saying, "Oh, my girlfriend showed me this new way to factor," and none of the math teachers here had ever seen it. And we're like, "What? That's so easy and nice." So, but it didn't have a name, so that's why I was calling it some guy's girlfriend's method. But now I just call it the new method. Okay, well, use it if you want. If you don't want to and you want to factor by grouping, that's fine. If you want to guess and check, that's fine. I don't care what you do, but you need a way that works for you and that works consistently. And it's nice to know more than one way. If you are a consistent guess and checker, that's fine. But like I said, when you get those two n terms that have tons of factors, that's a bit more annoying, right? However, guess and check is awesome when those n numbers don't have a lot of factors. There's only so many combinations, so you can get there pretty quickly. So it's up to you. All right, you want to try some on your own now? Yes, you're ready? Okay, let's hope that this recorded.